Okay, we learned the basic theory for estimation. Now we are going to extend our framework of estimation. When you estimate something, like for example, when you estimate the mean, usually you think about just answering by one number. Say the mean gas price is $10 per gallon. But when I say $10 per gallon, one important information is actually missing. That's one when you just answer with one number, it does not show how accurate or how confident I am in that answer. So, uh, like like you know that one number is almost always wrong. So you have to complement that problem by telling how much error you actually expect in your answer. So let's think about this example. It's like pregnancy due date. When my wife was pregnant, really the actual due date was February 15th, many years ago. And then at the time, so it's a serious problem. Uh, like some important questions I want to hear from the doctor was like, until when can she work? And can I schedule an important appointment on February 10th? At the time, I had to go to a conference. There was a conference about like on February 10th. Can I go there? So, and then just by the due date, if you just know this one date, it's useless to answer this. So even if the due date is February 15th, you know that the baby could come early or late. So it doesn't mean she can work until February 14th. Or so 5 days before, but this date may not be safe. So the due date, just one number, is pretty much useless to make the decision at the time. So what I would like to hear is something like this. It would have been more informative if I was told the baby will be born between February 5th and 25th. So then, okay, I can kind of schedule accordingly, or I can make a better plan and better expectations uh, when the baby will be born, so that I can be more ready by that time, right? So this is the idea of our estimation procedure, generalization of estimation procedure. We are going to generalize our point estimation into interval estimation. So point estimation is estimating a parameter by a single number, just like due date, or saying $10 per gallon. It is just one number. It is, of course, very useful because it's simple to understand, very intuitive what it means. But as I said, it does not tell you how accurate the estimation is. It is almost always wrong, but I don't know how much wrong it is. On the other hand, if you answer with an interval, that provides more information. So you tell not only just one point, but also you gives the accuracy. Like if you are more confident, you can be more specific about the about the parameter. But if you are not certain, if you don't have enough information, your estimator will be more diluted, like by giving a larger interval, right? So this is the structure of an interval estimation. Suppose that already point estimator is given. I will start from point estimation. So point estimator theta hat is already given, and what we are going to do is just we will allow a certain margin of error plus minus the point estimator. So we know point estimator is here, and then like we allow margin of error. So we know a certain amount of error is likely. So supplement the point estimator by the buffering the estimator by a certain margin of error. And then it becomes an interval. Upper confidence limit is the point estimator plus margin of error. So if there was a positive error realizes, then that's upper confidence limit. On the other hand, n minimum, the true parameter will be likely to be greater than theta hat minus m. So that's lower confidence limit. So it shows your confidence. You are confident that the parameter is contained within this interval. So it's called confidence interval, right? It's clear then what it means. So the true parameter is in between these 2 points. So then the interval estimation is correct. Now you can tell whether it is wrong or not. When there was only 1 point, it is almost always wrong, right? We learned 1 point has 0 probability in chapter 5 or 6. But now we have interval, so we can calculate the error probability. Usually error probability is denoted as alpha, which is the probability that the true parameter is actually smaller than the lower confidence limit. Lower confidence. So you believe the true parameter is in between the lower confidence limit and upper confidence limit. But if the true parameter was smaller than the lower confidence limit or greater than the upper confidence limit, then that's outside of those interval is the error probability, which is usually denoted as alpha. And then you can calculate, of course, 1 minus alpha is the probability of correct estimation. So 1 minus alpha is the probability that your interval contains the true parameter. We call that confidence level. It's a probability that the true parameter is in between lower confidence limit and upper confidence limit. So correct. You are correct with probability 1 minus alpha. So alpha is error probability. Okay. So far, it's clear we learned just point estimator, margin of error, and the probability of correct estimation is confidence level. Okay, now then let's think about this. Back to the pregnancy due date example. So suppose that it's just, of course, hypothetical scenario. Suppose that there are 2 doctors. First doctor told me the baby will be born sometime between February 5th and 25th. And there was another doctor, suppose, and then she told me the baby will be born sometime between January and March, right? And in this case, which is more informative? Which is more useful? Which information is more useful? Of course, it is estimator number 1. So this kind of like estimator, it is an estimator, but it's useless. You don't need any medical expert to say this, right? Even I could just tell this without asking to the doctor. So when you compare these two, estimator 1 is more informative. It tells me, okay, so I could expect the baby will be born here at this time. So second estimator contains little to no information, like no medical information is contained here. And then, but if you compare the confidence level, what would have the higher confidence level? Remember, the confidence level is the probability of correct estimation, or the probability that the interval contains the true parameter. What would be which one between these two estimators, which one has the higher confidence level? You don't need any calculation. The answer is the second one. As I said, second one must be correct almost always, right? Almost always it will be correct. But actually my son was born on February 3rd. So this estimator would have been wrong. Of course, I did not hear this kind of interval estimator at the time. Doctor does not tell you interval estimator. But if this was an estimator, it was wrong. But estimator 2 would not be wrong at all. So in that sense, estimator 2 has higher probability of correct estimation because it's greater. It contains almost all possibilities. So it has the higher confidence level. So what we learn from here is that those two comparisons are actually trade-off. So in the first question, I asked you which is more informative. And then for an interval to be more informative, I want the margin of error to be small. So the margin of error is small because there are more confidence, like more information is used. So you can make the interval more compact. You can be more confident with a small estimator, more informative. So margin of error was only 10 days, but it can be wrong relatively because the margin of error was too small. On the other hand, when the margin of error is extremely large, then confidence level is nearly 100%. But as I said, it contains no information. Anyone can say so bring me any pregnant woman, and then I can say the baby will be born anytime from now up to next year. Anytime so anyone can say that, and it will be almost always wrong, almost always correct, but there is no information. So these two are trade-off. Small margin of error will give more information, but higher probability of error, and vice versa. So that is the main idea you need to understand in the interval estimation. The smaller, so two desirable properties are small margin of error and higher confidence level, right? Smaller margin of error means there are more information, but higher confidence level means more likely to be right, but they are trade-off. So we have to balance between them. How do we balance them? We will fix the confidence level first. So we set how much we set the error probability we are willing to sacrifice. So I will allow 1% error probability. Then give me the smallest margin of error based on that confidence level. Or I can say, okay, I can sacrifice up to 10% error probability. Then give me more information, right? Something like that. So usually the confidence level is chosen among those 90%, 95%, or 99%. This means it is equivalent to choose your error probability. So you name how much error probability you want. Then I'll give you the most informative confidence interval that satisfies the error probability. That's the basic procedure. So then put it this way. Which confidence level yields the widest, the largest confidence interval? So simple to understand. So the larger the interval is, the more probability of containing the parameter. So it is more likely to be correct. So that means to make a 90% interval, for example, you need, say, this much interval. But to increase the confidence level to 99, you have to expand the interval to contain more probability for the parameter, right? So the answer is C. The larger the confidence level, the larger the confidence, the window of the confidence interval. So that's the basic trade-off and basic structure of confidence interval. In the next video, I'm going to use normal distribution to derive how to calculate the margin of error. So it will involve more algebra, but in the end, the result will be simple. But it's a very important algebra, and also based on the sampling distribution, so must be simple. Okay, see you in the next video. Bye.